तो भाग जाना यहाँ से। Good morning, student. How are you? I hope you all are fine. Right? You all prepared for the test? So you all know that Monday we have physics test, and the topic for the test is chapter 4, refraction of light at plane surfaces. So just quickly I want to recapitulate. So you all know that speed of light travels with different speed in different medium. So here I hope you all know that the speed of light maximum is in air, and that is 3 into 10 raised to power 8 meter per second. 10 less than that is in water, 2.25 into 10 raised to power 8 meter per second. Then in glass, 2 into 10 raised to power 8 meter per second. See, from this speed, what conclusion you can draw? It means the speed of light decreases when the medium becomes denser. So, maximum speed of light in air, or we say in vacuum, 3 into 10 raised to power 8 meter per second. Now, how will you come to know that whether the medium is rarer or denser? Say student, when the ray of light travels from one medium to other medium, and you all know that when a ray of light travels from one medium to other medium is changes, so it bends from its path, and this bending from the path is known as refraction. So when the ray of light bends near to the normal, towards the normal, so it is slow down. It means speed decreases. So this medium is known as denser medium. But when the ray of light travels from one medium to other medium, and it moves away from the normal, it means speed up. And when it is speed up, it means the medium is rarer. The medium is rarer. I hope you understood here. So, if you are asked to compare here, how can you compare between angle I and R? In medium rarer and in denser. So, in this situation, I is greater than R. But in this situation, I is less than R. Fine? So, what is refraction of light? I hope you all know. The change of direction of the path of light when it passes from one transparent medium to other transparent medium is called refraction. And what is cause of refraction? Change of speed of light in going from one medium to another medium. So simple way. What is cause of refraction? What is the cause of bending of ray of light from its original path? Change of speed of light. Now, this is very common question. When the ray of light incident normally, student, when we say ray of light incident normally, what is angle of incidence? 0. And when ray of light incident normally, there is no refraction. There is no change in its path. So angle I is equal to 0, angle R is equal to 0. Laws of refraction, I hope you all know. What is laws of refraction? There are two laws. First, the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. Second point, and this law is known as Snell's law also, the ratio of sine of angle of incidence to the sine of angle of refraction R is constant for a pair of given media, and this constant quantity is known as refractive index. So if you are asked simple, for two transparent medium refractive index to define, you can say that refractive index can be defined as the ratio of angle of incidence, sine of angle of incidence to the sine of angle of refraction. Does refractive index has any unit? No. Why? Because it is ratio. Now the second important thing, what is the absolute refractive index? Absolute refractive index, it is defined as the ratio of speed of light in a vacuum to the speed of light in that medium. It means absolute refractive index mu is speed of light in vacuum to the speed of light in that medium. Now here, see, as I say, speed of light in vacuum is maximum. So student, you should know here, absolute refractive index is always greater than 1. And what is the reason why it is greater than 1? Because the speed of light is greater than the speed of light in any other medium. Now, these kind of questions is very common question. Refractive index of glass is 1.5. What do you mean by this? Refractive index of glass, if you say this is 1.5. Are you getting me? So it means the speed of light in air is 1.5 times of the speed of light in that medium. So what is asked here? How can you say? Refractive index of glass is 1.5. It means that light travels in air 1.5 times faster than in glass. If instead of this glass, suppose diamond is there, so you can say in diamond. So you can define this. Now numerical based on this, suppose refractive index of glass is given 1.5. Just I took one example to make you understand how can you solve the numericals. Find the speed of light in glass. So you know the formula, mu is equal to refractive index of glass, medium is glass, is equal to speed of light in air upon speed of light in glass. Followed? But this is known quantity. Speed of light in air you should know 3 into 10 raised to power 8 meter per second. Substitute it on your own. It is not given but you know this. And speed of light v. You can solve it. But do not forget to write unit. See student, when numericals are given in the test or in exam, no marks will be rewarded without unit. If the question is given for 2 marks, without unit you will get only 1 mark. So make sure that you are going to write correct unit. Condition for light to pass undeviated. Undeviated means without changing its path. As in the beginning I said, when the ray of light incident normally. Normally when we say, then I is equal to 0. And the refractive index of both the mediums should be same. Mu1 is equal to mu2. Mu2. It means when the ray of light travels from one medium to other medium, refractive index should be same. Factors affecting the refractive index. It means what are the factors on which refractive index depends? Nature of the medium, optical density. Refractive index is more if the density is more, medium is more denser. Temperature, inversely proportional. Refractive index is inversely proportional to the temperature. The color or wavelength. Refractive index is inversely proportional to wavelength. So here student, very simple question you are asked. For which color refractive index is most? See, for the violet, wavelength is least. It means refractive index is most. Followed me? So for violet it is most refractive index and for the red it is least. Now another concept, principle of reversibility. Principle of reversibility state when a ray of light passes from one medium to other medium, it follows exactly same path when it passes from the second medium to first medium. So you can see the arrow. Reverse back. It means path of light ray is reversible. Followed? Now refraction through rectangular glass. Now here the two diagrams are given. And this is very important question. Here you are just in the exam asked to complete the ray diagram. When you are asked to complete the ray diagram anytime, anywhere, you are supposed to level each and everything. Fine. Suppose the glass block. Here the ray of light incident. Put here normal. So mention here incident ray. Angle between normal and incident ray is I. Then from air to glass, it means ray of light bend towards the normal. This. Again on this surface you draw the normal and the ray of light will now glass to air away from the normal. Followed away from the normal. But it should be taken care. The original path of the incident ray is parallel to the emergent ray. See the labeling, emergent ray. And the perpendicular distance between the direction of incident ray and the emergent ray is known as lateral displacement. You need to mention it, lateral displacement. Lateral displacement depends on few factors. thickness of glass slab. How? Directly. Lateral displacement is directly proportional to the thickness of glass slab. Angle of incidence, lateral displacement is directly proportional to the angle of incidence. Wavelength, lateral displacement is, sorry student, it is inversely proportional. It is not directly, it is inversely. And the refractive index directly proportional. Another question is asked, what is the relation between angle I and E? E is angle of emergence. So angle of incidence is equal to the angle of emergence. Which two rays are parallel to each other? Emergent ray and the original path of incident ray. Followed. Now refraction through the prism. See, if prism is kept in the minimum deviation position, each angle is 60 degree. Ray of light incident here, draw perpendicular, angle between perpendicular and incident ray, angle of incidence. This ray should be parallel to the base if it is kept in the minimum deviation. Refracted ray, this is refracted ray, parallel to the base. And then put here normal and the ray away. Glass to air away from the normal. So normal and emergent ray, angle between normal and emergent ray is angle of emergence. Now the ray proceed backward, emergent ray and the original path of incident ray intersect each other, and the angle form is known as angle of deviation. Angle of deviation. And this angle of deviation depends on few factors. This is again very important question. First is angle of incidence, and this is the condition which is very important because again angle of deviation you cannot say that directly or indirectly. You look at this. Here angle of incidence increases but angle of deviation is decreases. It means initially when angle of incidence increases, angle of deviation decreases. After minimum deviation, it start increasing with increase in angle of incidence. And on y-axis we take angle of deviation, on x-axis we take angle of incidence. Another important question it is asked, how angle of incidence, angle of emergence, angle of prism, angle of deviation, they are related. I plus E is equal to A plus delta. But for minimum deviation, angle I is equal to angle E. And the refracted ray must be parallel to the base of prism. Followed. Now, real and apparent depth. See, this diagram is shown for the bending of a stick. When you are asked for the real and apparent depth, this water in the beaker should be shown. This water. Got me? Now, the tip, this thing, point is here. From here, the ray of light incident normally, without deviation. Now, the ray of light incident at some angle here and draw here normal. It means from water to air away from the normal. Produce this ray backward. It will intersect. It means this point O shifted O dash. So it will bend here and it appears to be here. It means AB is the real. OO dash is the shift. And this PO dash is the apparent depth. Followed. Either it is bending of a stick or here any coin is given. So this point is representing as coin and diagram will remain same, or any other thing. Stake, pencil, anything. So this shift, see, relation between this refractive index is equal to real depth upon apparent depth, and shift is equal to real depth into 1 minus 1 upon refractive index. But this shift depends on few factors: refractive index and the thickness of the denser medium and wavelength. Refractive index more, shift is more. Thickness of the medium is more, shift is more. Wavelength is more, shift is less. So indirectly. Followed? Now numerical based on this. See, a coin kept inside the water. Refractive index of water is given. When viewed from the air in a vertical direction appear to be raised by 2 millimeter. Raised by 2 millimeter. Just I have drawn this diagram. This is coin and this coin is raised by 2 millimeter here. It means this is shift. Got me? So apparent depth is this one. If you say that this is real depth and assume that it is x and this is 2. So what is apparent depth? X minus 2. For this kind of question, student, you need to draw roughly diagram. Rough diagram you must do before solving the numerical. So mu is equal to real depth upon apparent depth. I have just told you how to do. Real depth is this. Or you can apply this formula, shift is equal to real depth into 1 minus 1 upon mu. Substitute all the value. Reciprocal, take LCM, solve, real depth is 8 millimeter. Answer will remain same. Now the concept of critical angle and total internal reflection. Just I'll explain over here. Take a point in denser medium. When a ray of light starts traveling from denser to rarer medium, this medium is rarer, it means ray of light away from the normal, refraction. Again the second ray, suppose this ray is refracted at the boundary, so this angle of incidence is known as critical angle. So what is critical angle? Critical angle is the angle of incidence corresponding to which angle of refraction in the rarer medium is 90 degrees. Understood? Now the third ray incident over here. In this situation, angle of incidence is greater than angle of critical. So ray of light will reflect back in the same medium. So this phenomena is known as total internal reflection. So how can you define total internal reflection? It means when the ray of light travels from denser to rarer medium in such a way that angle of incidence is greater than the critical angle total ray of light reflected back in the same medium. This phenomena is known as total internal reflection. See the condition for total internal reflection. From the definition only you can get the condition. Light must travel from denser to rarer medium. The angle of incidence must be greater than the critical angle. Now, critical angle for glass is 42 degree, you know. For water it is 48 or 49. For diamond it is 24 degree. You may ask to complete the ray diagram like this. See, this ray of light incident here normally 90. It means without deviation. Here, draw the normal. By angle some property 90, 60, so this angle is 30. Here it is normal, so this is 60. So this angle of incidence for this surface 60 is greater than critical angle 42. It means total ray of light reflected back. Again you wait here and calculate the angle. This is normal, this is 60. It will be 30. It is 60. 60 plus 30 is 90, so this is 90. It means without deviation, angle of incidence is 0 for this surface. So what I would like to say beta, at each and every surface you need to calculate angle of incidence. Here it is 30 degree angle, prism is there 90, 30 and this is 60. Here I have taken the ray of light incident normally. Without deviation reach this surface. At this surface, first you calculate this angle. This is 60, 90. 90 plus 60, 150, so it is 30. You have drawn here normal, so it is 60. Right? 90 minus 30 is 60. So this is more than critical angle. Up. Total internal reflection. This is 60. This is 30. This is 30. It means this complete angle is 120. But when you put this normal, this angle is 30 degree. It means less than critical angle. So it will bend away from the normal because glass from air. Refraction. Followed me? So now I would like to suggest you read your chapter thoroughly and you must see each and every example, back exercises, question answer as I discuss each and everything. So you please complete and thorough revision. In the test paper, each and every diagram must be drawn with the help of pencil and scale and labeling must be proper and take care of unit. All the best. God bless you. Thank you.